Hey everybody, it's Eugene Lisho here, and welcome to episode 59 of Forensics Talks. And today my guest is Karen Woodall, and she's going to be speaking to us about the opioid crisis, especially from a forensic perspective. Before we do that, just let me bring something up here, and that's just a quick announcement on one of the courses that I've got coming up, and that's in a couple of weeks from now. That's the Cloud Compare course. So I know many of you that watch this also work with 3D data or know somebody that does. And Cloud Compare is a great program if you're working with different types of like photogrammetry, laser scanning, and all kinds of different types of data where you can bring it together, you can register it, you can edit, create little cool animations, and even do different types of analysis. So if you're interested in that sort of thing, March 22nd and 23rd, it's 2 days, and you can just go to the website. Let me bring up the link here just for everybody. But basically, if you go to my website, you'll see it, and you can just pop on there and have a look. Okay, that's good. Also, don't forget, there is a comment section. So wherever you're watching from, please make sure to, well, first off, I like to ask people where they're watching from. So if you, let me just shut this off here. Yeah, if you can just go ahead and do that so I can know where you're from. And if you have any questions, of course, please put them in there as well. We are podcasting too. So every now and then I'm starting to catch up. I spent all last weekend doing about converting 10 of these things over to podcasts. So Apple Podcasts, Spotify, all the major podcasting services or directories, you can probably pick it up. So, and I'm starting to catch up. So many of these ones that I'm recording now, I'm going to very quickly put onto an audio format. Okay, so let's get going here, and let me get the bio set up for my guest here. There we go. All right, so as I mentioned, Karen Woodall is an assistant professor and forensic toxicologist within the forensic science program at the University of Toronto. In 1996, she graduated from the University of Bradford in the UK with a PhD in pharmacology. She worked as a forensic toxicologist at the Centre of Forensic Sciences in Toronto for 20 years before joining the University of Toronto. And as a forensic toxicologist, she regularly testifies in court as an expert witness in many different types of trials, including drug trafficking, homicide, sexual assault, and impaired driving cases. Karen is also a member of the Canadian Drugs and Driving Committee, which acts as an advisory body to the Department of Justice with respect to issues of drug-impaired driving. Her research interests include toxicology and the opioid crisis, the role of drugs in motor vehicle fatalities, and oral fluid drug testing equipment. And she is also a colleague of mine. And so we've sat in a few meetings together. So let me bring her in here. Hi, Karen. How are you?
Good, thanks. Hi, Eugene. Thanks for having me on today.
All right, excellent. Yeah, so let's get started with one of the interesting things in your bio was pharmacology. So I'm kind of interested in sort of the path that you took into forensic toxicology. Was that something you were aiming at the whole time, or were you actually looking to open up Woodall's pharmacy chain?
When I was younger, trying to decide what I was interested in for university, I was interested in kind of pharmacology. I love the study of drugs and how they work. And it's interesting, though, I always loved forensics, but this will age me a little bit. When I was younger, there were no university programs for forensic sciences. It was a job you could have, but you couldn't go to university to study it. So I sort of forgot about forensic science, did pharmacology, came to Canada. And when I was in Canada doing a postdoc, they were advertising jobs at the Centre of Forensic Sciences in the forensic toxicology department. And I thought, well, pharmacology, I know how drugs work, how they affect the body. Maybe I could apply. And sure enough, I was successful. I got a job at the Centre of Forensic Sciences. And they don't always mind if you don't have a forensic background. If you have the science background, they can train you in the forensic side of things. So they trained me in the forensic aspect of the job.
Okay. And so in terms of how would you explain forensic toxicology, or what the role of a forensic toxicologist would be to, you're at trial or just the regular person?
So forensic toxicology, it's the study of the adverse effects of drugs and poisons. And then obviously the forensic things means for purposes of the law. So forensic toxicologists often deal with death investigations. So if a drug has, caused death, or if it's played a factor in the circumstances surrounding death. So for example, if somebody's intoxicated and they get into some kind of accident, the accident, there might be a physical cause of death related to the accident, but the reason they got into that situation was because maybe they were drunk or they were high on drugs. So tox plays a role in that. And then in terms of criminal cases, drug facilitated sexual assault, toxicologists play a role in those. Homicide cases, again, sometimes it might be if somebody's been kind of poisoned, or it might be the behavioral effects of drugs at the time that the homicide took place. Also, I've done a lot of court involving drug trafficking cases, and that actually links to our topic today, which is the opioid crisis, because sometimes when judges are sentencing with people that have been drug trafficking and they've either pled guilty or they've been found guilty, the judges need to know, well, how serious is this offense? So I've gone to court and explained to the judge, well, what are opioids, especially some of the newer ones like fentanyl? They want to know just how dangerous they are. And so a toxicologist is in a good position to do that.
Okay. Well, you're sort of leading in right into the next question I had, which is to talk about the opioids. And can you give a bit of history on opioids and sort of where they came from and how they've led up to this crisis?
So opioids originally, opioids arise from the opium poppy. So they originally they were naturally occurring substances. They've been used for thousands of years, used for medical purposes, used for kind of recreational purposes. But now, if we talk about opioids, we refer to it as a class of drugs. So opioid drugs, they all act on opioid receptors in the body. Some of them are still these naturally occurring opioids. So morphine was the first chemical that was isolated from the opium poppy. So morphine, that's where it originally comes from. But now people have made various synthetic opioids that have no relation to the natural ones, but they have the same effect in the body.
I see. And so heroin was an early one, and I think like it was used. Was it a pharmaceutical initially? I think one of the pharmaceutical companies, like way back in before the 1900s, I think produced some of that for purchase.
Yeah, it was definitely used quite a long time ago as a pharmaceutical agent. In fact, it was even marketed. You could buy it over the counter like a few hundred years ago, and it was used for, like if you had toothache, you could buy these heroin drops to treat your toothache, which now seems kind of ridiculous. And then people started to discover that it had quite an addictive potential. So then stricter rules and regulations came in. Some countries, heroin is still legal. So there's some European countries where it's very tightly controlled, but in some circumstances you can still get it.
So then what happened? Like what happened in the late 80s or 90s that sort of caused this explosion in cases and addiction?
One of the things that kind of is the root of the current problem that we call like the opioid crisis, or sometimes you hear it called the opioid epidemic. It's kind of since the 90s, especially in North America, we've seen this kind of explosion of opioid use and abuse, skyrocketing deaths due to opioids. And one of the things that happened is in the 90s, there was marketing for opioid drugs. So one in particular, OxyContin, which the opioid drug is oxycodone, and OxyContin was this slow release tablet. So a slow release tablet means you take it, it gradually releases the oxycodone for like 12 hours. It's great for pain relief. People didn't think it was addictive, and the company kind of heavily kind of pushed doctors to prescribe it. So the number of prescriptions for OxyContin kind of exploded. And then when you have drugs like opioids that can cause, well, let me sort of back up. So opioids in general, one of the things that they're really good at is for pain relief. If you've ever had kind of minor surgery or you've gone into hospital for surgery, you might have been given like a prescription of an opioid. So they're very good at that. They also can cause euphoria, and that's one of the reasons why they get abused. They've got high addictive potential. So this oxycodone issue, more and more people were taking them. They were becoming addicted to them, and people were abusing them. So the slow release capsule, if you swallowed it, you get a nice slow release for over 12 hours. But people started to figure out that if you crushed them up, you could snort them, you could dissolve the contents, and you could inject them. So, it created this way for people to get a high from it. And this caused this a huge increase in deaths. But following on from that, what happened is when people finally realized what was happening, they started to control it more. So they tightened up the legislation. It was harder to get prescriptions for OxyContin. But now you've got this group of people that are already addicted to opioids. So then they switched and found illicit sources, which at that point was more heroin. So the opioid oxycodone deaths started to decline, heroin deaths started to increase. And then in the 2000s, around the mid 2000s, fentanyl, which is a synthetic opioid that is really, really powerful, that started to be used more widely and being prescribed. And then that created the kind of even worse in terms of the number of overdoses and deaths.
Okay. So can you explain the different types of opioids and maybe give some examples of each?
Yeah, so there's naturally occurring opioids. So morphine would be the sort of classic naturally occurring opioid. You get it from the opium poppy, you can extract it. Codeine, a milder type of opioid, is also naturally occurring. And then you've got a group that's called semi-synthetic. Heroin is an example of that. So with heroin, what you do is you slightly alter the chemistry of morphine to create heroin. So you still need the raw material from the natural source, but you chemically alter it to create something like heroin, which is gets into the brain faster, so it can actually be more addictive than morphine. So that's semi-synthetic. And then you've got full synthetic opioids. Now they have no chemical structure related to the naturally occurring substances. Like they're made in a lab, but they act in the body on the same way. So methadone, fentanyl, they're examples of synthetic opioids.
So is it fair to say, are there more synthetic ones, the ones that are actually most potent?
Yes, I would say the synthetic ones are most potent. It's actually interesting. So doctors have to be very careful prescribing opioids because they can be so, they're such powerful drugs. They can cause death if they're not prescribed properly. So they have these charts that are designed to show how strong opioids are. So in these charts, morphine is kind of the standard one, and it has a value of 1. Codeine, which is one of the milder ones, is like 1/10 of morphine, whereas something like heroin is 5 times stronger than morphine. Fentanyl is 100 times stronger than morphine. And then some of the newer synthetic ones, such as carfentanil, that's 1,000 times stronger than fentanyl. So, but if it's not for illicit purposes, if it's a physician, they look at these charts carefully. So they might say, okay, this person's been on morphine for 6 months, so we know that they've got some tolerance. If they want to put them on a slightly stronger drug, they'll adjust the dose carefully, but they're not going to put somebody straight onto fentanyl who has no history of opioid use. So physicians are very good at controlling what kind of dose that they would prescribe. From a forensic toxicology point of view, though, most of the cases that we see are unfortunately the illicit use of opioids where there's no tight controls to it.
You mentioned like, for example, someone's history. So what's the difference between somebody who's never used before, let's say that they're taking a dose for controlling pain or something, an accident happened, versus somebody who's a regular user? Do they become more tolerant?
Yes, so people become tolerant if they use opioids over a long period of time. In a clinical situation, you see this a lot. Maybe somebody's being treated for cancer, they've got chronic pain, so they'll be given opioids, and over time, they'll end up taking higher and higher doses because they become tolerant. They need to up the dose to get the effect. But it also means that their body can they can cope with the high doses. The same dose that somebody that's been on it for a long-term treatment, if you'd never been given an opioid before, that could be enough to kill somebody that doesn't have a history. And this is a factor with illicit drug use, because if you take a drug that you didn't realize you were taking it, maybe it's a stronger drug, or maybe sometimes somebody thinks they're buying, say, cocaine. Turns out it's actually one of these synthetic opioids. They have no tolerance to it. And that, unfortunately, is when they end up as a case file in, a forensic lab.
What about the ways that people ingest the drugs? Because you mentioned people crushing it, and then all of a sudden it maybe gives them a bigger kick. Are there any studies, or do you have any information on injecting it with a needle versus through the skin, or what are some of the differences, and what are their effects?
So in general, if you're taking opioids, the biggest high would be if you inject it intravenously. So intravenous injection of something like heroin, that's going to give you a big high. People can also smoke something like heroin. They can snort heroin. Other drugs, so the OxyContin that I was telling you about that came in tablet form, people would crush those up. They would snort it. They would dissolve it and inject it. Now, fentanyl is quite an interesting one, because fentanyl, when it started to be prescribed, it's available in the form of a pain patch. So a little bit like, I don't know whether you've seen, the nicotine patches if you want to stop smoking. So it's the same kind of technology, where it's a patch that you stick to your skin, and it slowly releases fentanyl, and you can wear it for 3 days. It's great if you've got chronic pain and you want chronic relief. The bad thing is that you've got 3 days worth of fentanyl in one patch, that if you're not used to it, then people started to abuse fentanyl patches. So the abuse of fentanyl patches, people would inject the contents of the patch, they would cut it up into strips and smoke the patch, and they would cut it up into little pieces and chew the patch. It's actually amazing when you sort of see all the creative ways people use to kind of get high from, their drug of choice.
You actually did a paper, I'm just going to bring it up on the screen here, but oral abuse of fentanyl patches, 7 case reports. And so when did you first start noticing this or seeing this was this during your time at the CFS, I imagine?
Yeah, this was sort of an interesting one. I was working on some cases, and I got a couple of cases. This was in the mid 2000s, and it looked like somebody had been chewing on something. They died, and they'd got this plastic sort of thing in their mouth. So the pathologist was investigating. We did toxicology analysis on it, and then we found that it had this fatal concentration of fentanyl. And then the investigation, they actually got the plastic that was found in the oral cavity of the woman that died, and it was one of these fentanyl patches. So at the time, I'd never even heard of this. Kind of asked around people in the community, nobody had really heard of this. So started to look into it, and then within a short period of time, we found like a number of cases with kind of similar. It was this oral abuse. So I called the chief coroner of Ontario and said, I think this is important information. We should sort of publish it. And he's like, oh yeah, definitely. And then he said, actually, I've been worried about the increasing number of fentanyl deaths we're seeing in the province. He's like, we should work on another publication too, detailing all of the deaths that are occurring. And so we also worked on another paper just to kind of show people. It was to alert them, like, what's going on. Yeah. it's funny. You look back; these deaths occurred in 2002 and 2004, and like in the early 2000s, we would get maybe 5 or 6 fentanyl related deaths a year. Then, like by 2004, we were starting to get 50 or 60 deaths a year. And if you look at the current data, we're now like the province of Ontario is getting well over 1,000 deaths kind of related to fentanyl use. So it really has exploded.
Yeah. In terms of, I mean, you've mentioned the person's sort of experience with the drug and how tolerant they might be, but also, what about genetically? Do you think there's any effects, like the way that people may genetically be able to process these drugs that could make a difference too?
Yeah, genetics does alter kind of drug metabolism. So sometimes the way that they metabolize the drugs, it can make a drug more toxic because, say, it might be a metabolite that's more toxic than the main drug that, so they end up with higher concentrations of the drug. So, and I think genetics too can come into play. So this is getting outside of my area of expertise, but the whole like drug addiction with opioids, we know that some people are more likely to sort of experience addiction issues. So I think genetics comes into play with that too.
Interesting. And on this last study that I had up here, one of the things that I found interesting was that in the papers, what you're trying to do is establish the level of this drug or the concentration of this drug in the person's body. And is that typically how you establish what are dangerous levels inside of a human body?
Yeah, it's trickiest for a forensic toxicologist because we're dealing with concentrations from deceased individuals, and you don't always know the circumstances behind the death. So you get a lot of clinical papers where clinical trials have been done, and you know the levels that you expect to see in people taking it that are fine. But we want to know, okay, but what levels can cause extreme toxicity or death? And one of the ways we do that as forensic toxicologists is you get case reports where you know that the cause of death has been linked to fentanyl. So in this research, it was great working with the chief coroner of Ontario at the time because we work with the coroner, and so we know exactly what the cause of death was listed by the coroner. We've got the toxicology findings, and then you can start to sort of build a bigger picture.
In terms of the laboratories, there's actually another paper here. Since we're talking all research papers now, it talks about strategic decision making, and so sometimes I just think that everybody knows, but with the prevalence of all these new drugs that start popping up all of a sudden, the labs are sometimes playing catch up. Does that make sense? Like they're trying to figure out what this drug is and how to detect it properly, and then figure out the concentrations that are involved in these death cases.
Yeah, it's a really big problem now in forensic toxicology labs. It's it's interesting times for forensic toxicologists, but it's also challenging times because we're getting new drugs that are appearing in the sort of the illicit drug market, and so for a lab, they've got to make sure that they can test for the drug, they can test for it at the relevant concentrations, and then also right now, you get kind of novel illicit drugs appearing rapidly in the market, and then sometimes they're here for a few months, then they disappear. So, as a lab, where do you put your resources into? So, the paper that you were just showing, that was looking at carfentanil, which is one of the most powerful opioids that there is. It's so powerful that it's never been approved for use in humans. It's actually approved for use. Vets can use it in large animals. So large animals, it's things like it's an elephant tranquilizer. We're talking kind of big animals. So in about 2016, it started to appear in Canada, and people were buying carfentanil. People started to. We knew it was getting involved in deaths, but as a lab, we had to establish a method that was sensitive enough to see carfentanil because it's such a powerful drug. It's very, very low concentrations are enough to cause death. So it's very hard for a lab to kind of keep up with this kind of thing.
The effects of the opioids on the human body, like it always comes up respiratory depression. So what does that actually mean?
So it opioids are central nervous system depressants. They slow down the way the brain functions, and part of the way the brain functions and part of the brain is the respiratory center. So normally, when you're breathing and it's automatic, you don't even think of it. But if you're under the influence of an opioid, your breathing starts to slow down, but your body can't react to it, and it can't compensate. So eventually, somebody stops breathing, they go into a coma, and then eventually that's the cause of death. So it's the slowing in breathing rate. It's interesting, actually. So from a forensic toxicologist point of view, sometimes if you're looking at cases and you're trying to decide what drugs you think that were involved, one of the things I learned many years ago, that people that were under the influence of opioids, one of the symptoms that their friends and family will report is that there's really, really loud snoring. So you'd hear this history, like friends out partying late at night, passed out on the couch, and then the person that's the deceased, it was last heard snoring really, really loudly.
Hmm.
And I remember talking to a pathologist going, this is really interesting. And they were saying it's because of the breathing rate being depressed. They're struggling to breathe. It's causing this kind of loud snoring. Sometimes when I tell people this, I always think, like, obviously we know that there's lots of other reasons for people snoring. So, if your partner at home is snoring, you don't necessarily have to worry. But if it was, kind of people out in a party situation and somebody's been doing drugs and somebody's passed out snoring, that could be a sign that they really do need assistance.
Yeah. Have you seen a change in where people are getting these drugs from over the years? Like, for example, starting around 2000 and then today, are many of the deaths due today because of prescribed stuff, or is it because of illicit, or have you seen a change in that over the years?
There's definitely been a change. So kind of in the 90s and the early 2000s, it was all kind of prescription. So whether it was prescription oxycodone, prescription fentanyl were the main ones. Occasionally, when you saw heroin deaths, you knew that was illicit. But oxycodone, and then in the 2000s fentanyl, it was prescription. Now, sometimes it was still illicit use because there was a big trade with people getting their prescription fentanyl patches and selling it on to other people, but it still came from kind of a legitimate source originally. Then I'd say maybe around 2012 onwards, started to see a shift, and powdered fentanyl started to be seen on the streets. In Canada, the problem really seemed to start in BC, and then it kind of came across the country, and then not long after we saw it in Ontario. But powdered fentanyl, it's relatively easy to make. The ingredients could be imported easily, high profit margin. So it's a lot easier to make than something like heroin. So we really did start to see this big shift. And the powdered fentanyl at first, people didn't realize they were buying fentanyl. They thought they were buying heroin. But, heroin is like 5 times stronger than morphine, but fentanyl is 100 times stronger than morphine. So you see, there was this big issue where people really didn't know what they were buying. And again, that caused a lot of problems.
Was carfentanil I don't know if you know this or not, but was carfentanil manufactured illicitly first, or was it something that a drug company created first?
So a drug company created it first, and it is approved for use in veterinary clinics. Certain clinics have approval for it. It's never been approved for use in humans. So all of the illicit things that we're seeing now for carfentanil, that's made illicitly. Actually, I have some stats here. So this is from Health Canada data. So it was saying that 90% of the accidental opioid deaths in 2001 involved a non-pharmaceutical opioid. So I thought that was interesting.
Mm-hmm. Mm-hmm. Yeah. So people are, well, they're getting it somewhere on the streets, and when they do buy this stuff on the streets, they don't know. I mean, they don't know what it's laced with, or they don't really know how much fentanyl is in there, if it's carfentanil or whatever, right? So
Yeah.
that must be an issue as well with overdoses, no?
It's a huge issue. For a while, I remember working on a lot of cases where the history would be kind of known heroin user, bought heroin, found later that night, vital signs absent, they don't recover. We wouldn't find any heroin. We would find fentanyl. It was fentanyl that they'd taken, but the history and interviews with their friends suggested that they had no idea they were buying fentanyl. It was, they thought that they were buying heroin, and they thought that they were used to taking heroin.
You had mentioned something about, for example, testing, where people can actually test their drugs, or is that something in Canada right now, or where is that globally?
Yeah, so in Toronto, for example, there's a Toronto drug checking service where, like, this is all part of harm reduction kind of policies, public health policies. So the service is that if people have they bought their drug, they know that they're going to use it, but they want to make sure what the drug actually is. They can submit a little bit of the substance to this drug checking service. They will test it and they will let them know. So they might say, okay, this drug is 60% fentanyl, but it's 40% carfentanil. Or they might say, oh, this is all like heroin. So it gives a way for people to realize exactly what they're about to use.
Yeah, that makes sense. Yeah, so I just saw this one. This was March 2nd. It says New Mexico bill allows testing to prevent fentanyl deaths. So they're doing something here. I don't know if it's the same, but just trying to get the deaths down, and even spread of diseases like HIV and
Yeah.
hepatitis and stuff like that. So yeah, there seems to be a move towards getting some devices in place so that people have recourse, or they have a place to safely, like these safe injection sites and things like that. Actually, Portugal was kind of interesting. There's some interesting things on Portugal and the way that they treated some of the problems that they had, because I believe at around, I think it was in the 2000s or so, something like that. They had something on the order, like well over like 400 deaths a year in a small country. Like I think they only had like a population of about 10 million people. So they really turned things around. And I think today they have something on the order of maybe like 30 deaths, or at least maybe back in about 2017, they had reported something like 30 deaths. So do you know of any, there's some drug. Well, let me ask you about the programs, and then maybe some drugs which help with getting people off of these opioids.
So I know that, so for example, you mentioned Portugal, and I know that they've been a sort of a bit of a leader in terms of harm reduction. So, the thought behind it is they know that people are going to be using these types of substances. You can't necessarily stop them, but you can reduce, some of the harms from it. So, yeah, in places like Portugal, you could legally get heroin but it would be under a controlled environment, so you would know exactly what the drug was, how much you were getting. And I know it's been really, really successful, as you said, reducing the deaths in those types of countries. It's not very common, but in Canada, there are very limited circumstances where you can actually get heroin in Canada legally. It's for drug addicts that have tried other programs that haven't been successful, which actually leads me to, I think one of your questions was about other treatments. Now, there's something called the methadone maintenance program that's available in Canada. And methadone is also a type of opioid, but it's very useful for treating people with opioid addiction, because one of the things, if you're addicted to opioids, if you go into withdrawal, it can be really, really, that can be serious. It can be really difficult to go through withdrawal. So, it's a barrier to stopping using opioids. Methadone, if you take methadone orally, you don't get the same high. It can be controlled. It stops the cravings, it stops the withdrawal, and you get a certain amount of methadone prescribed to you regularly. So some people can be on the methadone maintenance program for years and years and lead perfectly normal lives. So it can be a successful program. It's very tightly regulated, like who can prescribe methadone, and people on the methadone maintenance program have to agree to regular drug tests to make sure they're not taking other substances.
Yeah, I believe in Portugal they actually have like it looks like a food truck, and you come up and they give you like a couple little squirts of you drink it. I believe it's in a liquid form,
Yes.
and then so is it just does it still give you the like somewhat of a high or anything, or is it just more it stops the cravings?
It stops the cravings, stops the withdrawal, like because you're not technically into withdrawal because you do have an opioid in your body. So it can work really, really well for a lot of people addicted to opioids.
Then what is it naloxone?
Oh yes, so naloxone is kind of what we'd call like the antidote to an opioid overdose. So opioids bind to opioid receptors; they have an effect. Naloxone is what's known as an antagonist, so it blocks the receptors without having any effect itself. So the good thing about naloxone is that it's not dangerous by itself. You don't have to worry about giving somebody naloxone, even if they weren't under the influence of an opioid. You're not going to do any kind of damage to them. But if somebody does have an opioid, if they are suffering from an opioid overdose, and you give them naloxone, it will immediately reverse the effects of the opioid overdose, and it really can be life saving.
I see. Um, you've done some. I wanted to talk about some of the writing that you've been doing because I know that you've got something coming out a little bit, and I may jump around here back with some other questions, but you have a book that you're writing. It's Wigmore on opioids. Is that correct?
Yes.
Okay, and Jim was a guest several weeks ago on here, and he has Wigmore on alcohol and Wigmore on. I think he has is it cannabis and
And Wigmore on nicotine is coming out soon.
okay.
So yes, they're a great series of books, and they're designed for kind of medical legal people that they're not toxicologists themselves, but it's a way of summarizing kind of the scientific literature, providing kind of what the research is, providing information for people that want to know about the topic. So James he's always had an interest in kind of alcohol, like cannabis, and in recent years he's got into nicotine research. He knows that I've always been interested in kind of the opioids. So he said, hey, would you have any interest in continuing the Wigmore on books, but kind of working on the opioid one? And so I said, yeah, definitely. So currently working on that, and hopefully kind of by this fall, the book should be ready, like for the publisher. So
Okay. Oh, interesting. Well, yeah, hopefully you'll have to let us know when that comes out, and
will do.
can give you a shout out on it. I wanted to ask you about the just recently, actually, there was like a big settlement with the one of the big companies, the pharma companies, and can you talk to a little bit about what happened there?
Yeah, I think it was Purdue. It was the company. So they're the company that kind of produced OxyContin. And so some of it, I'm not kind of aware of all of it. Some of it's kind of not necessarily tox related, but the general sort of background is because that was the main drug company that produced OxyContin, they were sort of involved in heavily kind of pushing physicians to prescribe OxyContin, kind of trying to stop some of the research that was coming out to show that actually it is a problem, and like this is addictive. So that's one of the reasons, because this whole opioid crisis has destroyed so many lives, destroyed so many families. So yeah, it's like a huge settlement in the US, but it's because they were the company behind OxyContin, which is kind of widely considered that was kind of the sort of the precipitating factor for the sort of modern opioid crisis.
I'm interested in your opinion here. Do you think that early on it was relatively apparent that these were highly addictive drugs, and that they were being misused?
You know what's interesting about this? So I think maybe it was in the 80s. There was a letter published in a medical journal that essentially said opioids aren't addictive. And they quoted a study, I think it was probably oxycodone maybe, that had been given to patients kind of in hospital. They didn't have any kind of addiction like issues, but it wasn't really a scientific study. It was just kind of a letter. And then that letter, so not a peer-reviewed research article, just a letter to the sort of editor, got quoted and re-quoted as scientific proof that opioids weren't addictive. And it's turned out to be kind of one of the major scandals, if you like, in this whole kind of area of research. And it's a reason to show that you always have to go back to the original source when people kind of quote research. But I guess not to get off topic too much. So going back to your question, I think at first a lot of doctors genuinely thought, okay, like, we've been told it's not addictive, we don't have to worry. But then I think it gets to the point where if you're regularly prescribing opioids to people, I think it was becoming obvious to a lot of people that they were addictive. I know that some physicians got their own personal lawsuits because they were prescribing kind of way too many kind of opioids to individual people. So I think that I think some physicians had no idea. Some physicians, I think, knew exactly what they were doing.
So what were some of the challenges that you feel you had at the CFS? And I don't mean, I just mean in general. Like, for example, what are some of the challenges that toxicologists face? Even issues surrounding I mean, for example, you talk about you're sort of on the back end because people die, and then you're trying to figure out, the level of toxicity. Like, do these drugs, do they disappear quickly in the system?
Oh, that's a good question. Luckily, with opioids, mostly that they're quite stable. So let's say somebody dies, they're not going to disappear from the sample. So you're able to test for them even kind of months after death. So that in itself doesn't tend to be an issue. Sometimes with some of the stronger drugs, it was hard to get methods that were sensitive enough to sort of see them. So carfentanil, for example, when a method first came out at the Central Forensic Sciences, the lowest concentration that we could see was already higher than we knew that could cause death. So essentially we knew we could be missing a lot of deaths here. When we got a more sensitive method, we kind of went back and reopened cases to sort of find carfentanil in some of the older ones. That's definitely an issue. And then you have an issue of interpretation. So if somebody dies with a high concentration of a drug in it, if you don't know whether they were tolerant or not, like, well, you don't always know if it caused death or not. Fentanyl undergoes something called postmortem redistribution, which essentially means after death, changes occur in the body. And so the fentanyl concentration in a blood sample can actually artificially increase.
Oh, okay.
So it's like, okay, you've got this high concentration, but maybe the person hadn't overdosed. Maybe it's just you get these post-mortem changes that occur.
So let me get this straight. So at first, when carfentanil was out, the equipment you had was only sensitive to a certain level, but you knew that that amount was already more than could be required to kill
Yes.
somebody.
Yeah,
Okay.
exactly. So
And
I mean, you can see how frustrating that is.
yeah.
Yeah.
And in terms of the equipment that you use, what kinds of techniques do you use to look at, looking for these drugs?
So use like liquid chromatography, mass spectrometry. So it's like LC-MS. It's the gold standard now in forensic toxicology. So really high tech equipment, but it's not just the equipment; it's getting the actual methods. So it's kind of how do you extract the drugs from the sample to get it onto the instrument, because you have to clean up the samples. You can't just put a blood sample into the instrument. So you do extractions to maximize the drugs that you're looking for. So developing those kind of methods it kind of takes time, and you can play around with certain kind of criteria to the method to try and make it as sensitive as possible. So there's a lot of work that goes into validating a new method when a new drug appears kind of on the market.
What about the software for the machine? I'm just curious if is there any like post-processing or intelligence that goes into some of this to help clean up, or is it just a simple, we're just measuring a certain amount of a chemical or something like that?
So the instruments do have a lot of software kind of involved in it. So kind of you run it on the instrument, it gets extracted. It's like liquid chromatography. So the compounds of interest get separated. It gets detected kind of on a mass spec. But then the software that gets involved with that is kind of a really big thing now. So for example, if you're screening for a new drug, there's lots of what we call them. It's like libraries of all different drug spectrums. So you can get different kind of libraries of thousands of drugs that you can run your results and kind of see, okay, is it one of these other compounds in this library? So there's definitely a lot of kind of computer and software involved in analytical toxicology right now.
Interesting. And are you, I'm not sure if you're mentoring any students or supervising any research students this year. Are you, in fact, or?
Yeah, so this year I'm supervising a student. She's looking at some kind of novel benzodiazepines. And it's interesting actually because often benzodiazepines are used with some of the opioids, kind of with drug abuse. That's what she's looking at. And then actually one of the students I supervised last year, we did a project looking at opioid deaths in correctional facilities in Ontario, because you actually can get quite a few drug deaths that occur in correctional facilities. You know, people get the drugs in. So we looked at a 10-year period from 2009 to 2019. There was something like it was over a 300% increase in opioid deaths in correctional facilities in Ontario. Those were all related to kind of fentanyl and then later on carfentanil.
Well, the amount is so small. It doesn't, it's not like you're bringing a whole a huge jar in. I mean, it's a tiny
Yes.
amount, right?
Yeah, a tiny amount. Yeah.
Yeah. And in terms of areas that are what often call low-hanging fruit, areas which require more research, or areas which require like, these are huge opportunities in toxicology. Are there any areas in your mind which require more research and more information?
I think the research in terms of the opioid crisis, so more information about kind of which opioids are being used, what drugs are they used in combination with, kind of demographics of like who's using them, things like how are they using them. It's one kind of route of administration. Is that causing more problems than another? There's all sorts of kind of areas that I think that would be great research projects.
Um, at the beginning, there was something in your bio. It was a group. It was a Canadian Drugs and Driving Committee.
Yeah.
Can you talk to me about what your role there is, or what you're doing there?
Yeah, so the Drugs and Driving Committee, it's an organization comprised of forensic toxicologists and other sort of subject matter experts. And it's all about kind of drugs and driving. And our role is we're the scientific advisor to the Department of Justice, so the Federal Department of Justice. So anything involved in drug impaired driving, the government wants scientific expertise before they set laws. So, for example, laws such as the per se limits for THC in driving, like zero tolerance for certain drugs, say like cocaine. The government wants to get feedback from scientists about what they should do. We also are involved in any of the drug testing equipment, so oral fluid drug testing. We have to approve an instrument that it's suitable for use before the government will kind of sign off on it and allow manufacturers to sell it to police organizations. I think there's currently about 8 of us, so it's all across Canada. So we have scientists from the RCMP, the Centre of Forensic Sciences, the Quebec lab, the forensic lab in Quebec. We're the ones that sort of meet regularly, and if the government wants opinions on certain topics, we'll provide that scientific background.
I remember talking to Jim, and he was talking about, for example, like cannabis, and like check, if somebody's driving, you stop them off, and then looking at the ways of analyzing that. But are there any instruments? Is anyone looking at field instruments, things that police can have, and they can check a driver like right away, or is it just all through the blood? Is that the only option you have?
So right now, we police have the ability to do oral fluid drug testing. So it's a sample of kind of saliva from your mouth. Right now, the only compounds that they're approved for use for are THC and cocaine. In the long run, the technology can test for other drugs, so methamphetamine, opioids, things like that. Right now, the only ones approved for use in Canada can detect either THC or cocaine. But especially for THC, it's a great way of showing that there was recent use of cannabis. So they were approved for use in Canada in 2018, so they're still kind of relatively new. But definitely, I think there's a good role for that type of fast drug testing.
Right. I'm just looking at the time. Just a couple more questions. One in particular has to do with just the whole COVID situation. Has there been a noticeable increase in use in drugs recently because of this whole situation? Like I've been hearing all about, people just depression and all kinds of things going on. But what information do you have there?
Yeah, so there has been an increase in drug deaths. A lot of those drug deaths opioid related during COVID, and as you say, it's a combination of factors. So unfortunately, you've got kind of say the increased depression. People have been in awful circumstances, and then you've also got the isolation. So if you're using a drug alone and you overdose, you don't have a friend around that maybe could give you the naloxone or call 911 for help. So definitely kind of an increase in drug deaths during COVID. I've got some stats here actually. So since this is from Health Canada, so it's Canadian data. Since COVID, there was almost 7,000 opioid deaths occurred. So this is April 2020 to March 2021, and it was an 88% increase from the same time period prior to COVID. So an 88% increase in opioid-related deaths.
Yeah, I think that's, I know because I have a lot of police contacts all over, and some of them are probably watching here. I know that many of them have said the same thing, that they're getting a lot more overdoses, and they're finding a lot more problems with drugs and things like that. So that's, it's an unfortunate byproduct, I guess, of the whole COVID situation.
Well, one thing I want to mention, I find it interesting. So in recent years, police have started to lay more criminal charges. So if somebody dies of, let's say, a fentanyl overdose, and it's somebody else that supplied that fentanyl to them, they're actually laying charges. So like perhaps like a criminal negligence causing death. So they can be challenging cases, but I think they're really kind of trying to go after some of these people to show, look, you've got to have responsibility. If you're selling a dangerous drug like this or giving it to somebody else and they die, like criminally, you can be held responsible. So that's something that the last few years that's becoming more common.
Right. I'm going to take one question here. Let me just put this up on the bottom here. Interesting question. He says, why are the toxicology results the slowest part of the autopsy report? Is it limited equipment, or is there an incubation time period for one of the tests?
Sometimes it's because so they do the autopsy and then they collect the samples, they send it to a toxicology lab, and then some of the tests can be relatively simple, but when you work in a forensic lab, it's not as simple as doing one test, then you send off the results. If it's an accredited lab, there's a lot of different checks and balances. So you have to repeat the analysis. It's got to be confirmed to make sure it's accurate. Then people have to check the results. So they can be slow. Some of it's to do with the checks and balances that are in place. And then some of it is due to, a lot of the time, it's like human resource issues. Forensic labs often, they could always do with more people working there. There's sort of backlogs. So yeah, that's one of the reasons.
One of the things I didn't ask you about actually was just your testimony in trial as a forensic toxicologist and sort of relating some of this information. I'm just wondering what some of your experiences have been in terms of when you come up as a forensic toxicologist, are people fairly nice to you, or do you often get pretty well challenged by defense people?
It can depend. Sometimes it's relatively straightforward, no challenges. Other times it can be heavily challenged. So I guess it depends on the different lawyers that are involved. It depends on the type of case. Most of the time it's not too bad, but everybody has the right to challenge. Like, you got to make sure that the person knows what they're talking about, so you have to go through your qualifications. But
Right.
like sometimes it takes a few minutes for the judge to say, okay, fine, you can testify on this. Sometimes it can be 3 or 4 hours of going through the CV, going through the qualifications,
Yeah.
for the judge to make sure that, yeah, okay, I'm going to let her testify about this.
And do you have any sort of what do I say, techniques or methods that you use? Like, for example, when you're communicating with the jury, because you may be dealing with a lot of chemistry and numbers and things like that. I'm just wondering if you sometimes explaining things, you try to simplify things for the jury, or how you handle that.
I definitely try and keep things simple for the jury. And in fact, my style is to keep things as simple as possible. So sometimes I'll say to the lawyer beforehand, I'll say, okay, I'm going to be giving really short, simple answers. So if you feel I'm not giving enough detail, like, make sure, like, follow up, because I don't want to just come out with a bunch of technical thing that nobody's interested in. So I'll start simple. If they move on to the next question, I think, that's good. Sometimes they'll prompt me for more things, but I always think you got to remember that people on a jury, a lot of them maybe haven't taken any science classes, and they drop them as soon as they can. It's easy to lose them.
Yeah, no, definitely, for sure. I always say the pathologists get the free ride. They always get they can say whatever they want. They get the free ride.
Yeah, definitely.
Right, yeah. So anyway, well, look, we're getting on in time. I think that's great. If somebody, I know that people can find you through the University of Toronto, through the website, University of Toronto, Mississauga. You're in the
Yeah.
Forensic Sciences program.
Yeah.
You're also on LinkedIn.
Yeah, LinkedIn, and then, as you said, the University of Toronto. My email's on the website. So if anybody has any questions, feel free, email me. I'm always happy to answer questions.
Excellent. All right. Well, look, thank you so much. I really appreciate your time. It was a great conversation and good, really great information here as well. So, yeah, thanks again.
Yeah, thanks for having me on.
All right. Hey, hang back for a second. I'll come back and chat with you in a second. Okay, folks, that does it for this week. That was 59. So next week's going to be number 60 if all goes well, and I get the guest to confirm. Still working on something, but should be a pretty good one if all goes well. Again, don't forget there's that Cloud Compare course that's coming up March 22nd and 23rd. I want to thank everybody for their time, for listening, and for the questions and that sort of thing. So hey, have a great day, everyone, and hopefully we'll see you next week. So take care. Bye-bye.